This is the third video in 1.3 of APAB. We're doing the last kind of evaluating limits algebraically, which is talking about rationalizing. So the hint that you want to rationalize an expression is that it has roots in it, and when you plug in, you get 0 over 0. So rationalizing is a thing we specifically do with roots, and the idea is that what we create is a difference of squares pattern to get rid of the roots that we have. Okay, so let's look at E5. I gave you an A and a B because I know this is the thing that most of us are probably less comfortable with, so I thought we should probably practice it a little bit extra. So when I plug in, and I should plug in, even if it's just in my own head, right? When I plug in for A, I'm going to get root 4 minus 2 on top of a 3 minus 3, which is definitely 0 over 0, right? Because it's 2 minus 2 over 3 minus 3. And remember, that's never, ever, ever the answer, but we should still do that because sometimes a teacher gives you a crazy-looking root expression and you think, oh my gosh, I have to rationalize, this is horrible, and then it turns out you could have just plugged in and it would have been fine. So you should always plug in just in case somebody's laying a trap. So, all right, so I plug in, I get 0 over 0. So the trick here is that what I want to do is I want to rationalize the root floor, okay? And when I say the root floor, so I mean the floor that has the root that's causing the problem. So rationalize the root floor. That's not like a clever math term, that's just a Hoganism. But what I want to do is rationalizing means create a difference of squares pattern. So I already have an A minus B, where A is that entire root. What I want to do is I want to multiply the top and bottom of this expression by A plus B. So A in this situation is the square root of the quantity x plus 1. So my A is going to be the square root of x plus 1. That whole thing's my A, plus my B is going to be the 2. I have to multiply by 1 if I don't want to change the expression. So I put that on both the top and the bottom. Now what I'm going to want to do is I'm going to want to FOIL out the root floor, okay? And again, that's not a math term, that's just a Hoganism. But the floor that has the roots on it, which is sometimes the top floor and sometimes the bottom floor, that's why I gave you two different examples here. I want to FOIL that out, and I don't want to FOIL, so I want to leave this floor factored. And the reason I want to do that, and I say this as someone who's done this problem a lot more times than you probably ever will in your life, because I've been doing calculus pretty much nonstop since 1997, and will continue to do so probably for a very long time, fingers crossed. So anyway, point being, I do a lot of calc, and so I've done this problem a lot, and what's going to happen is that ideally this factor is eventually going to cancel. This x minus 3 somehow is going to magically cancel and go away, right? But that won't happen it will still happen if you FOIL everything out, but you're going to have to like refactor it, and you're going to be really miserable, and just trust me, it's not a good idea. So you want to FOIL out your difference of squares and leave the other floor factored so that something can cancel. So let's go ahead and walk through that. So if I FOIL out the top, and I'm going to go ahead and put my equal over here, root x plus 1 times root x plus 1 is just going to give me an x plus 1, because when you times a root by itself, the root cancels and you're just left with the stuff inside the root, right? And then outer and inner will cancel, because I'll get a plus 2 root stuff minus 2 root same stuff, which is the whole purpose of the difference of squares. So the outer and inner will cancel, leaving me with just a minus 4 at the end. On the bottom, I'll have this x minus 3 times this ugly square root of x plus 1 all plus a 2, right? And again, this is kind of the target factor that I'm trying to cancel, right? So I'm hoping that the top magically becomes an x minus 3 or some multiple of an x minus 3. And whoa, it's totally going to happen. So, totally not an accident. If it doesn't happen, it's you, not the math. Okay, so I get x plus 1 minus 4, which is an x minus 3. On the bottom, I also have an x minus 3 times this ugly root x plus 1 plus a 2. Well, now these factors cancel, leaving just a 1 on the top, right? So limit, as x approaches 3, 1 on the top of this root x plus 1 plus 2. Is a 1 over root 4 plus 2, which is a 1 over 2 plus 2, or a 4. So 1/4. Notice I stopped writing limit when I plugged in. So a couple things to note. You're going to forget to write limit sometimes. You saw me almost do it like here and maybe up here. If you have to squeeze in limit as x approaches 3 really tiny in front of your work, no math teacher ever is going to judge you. We know the secret. We've all forgotten to write limit. Just make sure you go back and check that you included limit in every step. Limit as x approaches whatever number it's approaching at the start of every step. Notice that it comes after the equal sign. The reason that happens is because it's sort of like this is a big old math command. Limit of this stuff. So it's equals this math operation of this stuff. Equals this math operation of this stuff. right? If you need that parentheses to help you, that's great. If you don't, that's also fine. All right, so let's walk through B, and then I'll give you an a P5 to try on your own. So you can plug in, but the same darn thing's going to happen. You're going to get a 32 minus 32 on the top, and you're going to get a 4 minus 4 on the bottom. So again, you don't have to show me that you plug in. I just think you should do it for your own well-being, because someday I'm going to leave you a trap, and it's going to look like a disgusting, ugly problem, and if you would have just plugged in, you would have gotten the answer in about 5 seconds. So it's always a good idea to do the plug-in, just in case it's a trap. Thank you, Admiral Akbar. So in this situation, this is my root floor, the root x minus 4. So what I want to do is create a difference of squares. This is my a minus b, so I'm going to multiply by root x plus 4 on both the top and the bottom. Right? So when I do that, I'm going to get the limit as x approaches 16. Now remember, I'm going to leave this 2x minus 32 times this ugly monstrosity because I want something to cancel. Some part of this factor is what's going to cancel. On the bottom, when I FOIL my difference of squares, right, because this is an a plus b, my first ends up being root x times root x, which is just an x. My outer and inner cancel. I get a 4 root x minus a 4 root x. They're gone. That's what happens with a difference of squares. And then I get a minus 16. Now, you might be saying, oh, that's great, Hogan, but my factor doesn't cancel. Come on. Well, I would argue that your factor does if you take out a GCF from this ugly 2x minus 32. So you're going to get the limit as x approaches 16 of a 2 times an x minus 16 times this root x plus 4, right? All over an x minus 16. Oh, look how convenient. There goes the x minus 16s. Now I get a 2 times this root 16 plus 4, which is definitely a 2 times an 8, so my answer is a 16. Which is just a coincidence that the answer ends up being a 16 and you were plugging in 16. I assure you it's just a coincidence. All right, I'm going to give you a P5, and then you can try some problems that look like these crazy messes. All right. So again, we're evaluating the limit. So for P5, let's do A, the limit as x approaches negative 2. We'll do the square root of x. Let's do plus 3 minus a 1, and let's do an 5x plus 10 on the top. And then for B, I'm going to give you, let's do the limit as x approaches 4, and we'll do 2 root x minus 4 on the top, and we'll do x minus 4 on the bottom. All right, so cool. Give them a try. Pause me. I'm going to go ahead and do them now. All right, so I assure you that when you plug in, you do get a 0 over 0, but you should check anyway. I get negative 10 plus 10 on top of a root 1 minus 1, which is definitely 0 over 0. So I'm going to rationalize by creating a difference of squares on this root floor. So I'm going to times by a plus b, which would be root x plus 3 plus a 1, and root x plus 3 plus a 1. All right, so kind of give myself a little bit of space there. All right, so I end up with a limit as x approaches negative 2 of this 5x plus 10 times a root x plus 3 all plus a 1 over, and when I FOIL the bottom, the outer and inner are going to cancel the roots, the first is just going to cancel the roots, and I'm going to get an x plus 3. The outer and inner are going to cancel because when I create a difference of squares, the OI sums to 0, and the last will be a minus 1. So on the top, I see this 5x plus 10 and recognize that it has a GCF of 5 times the quantity x plus 2 times this root x plus 3 plus 1, right, because this is my GCF of that top term right here. And on the bottom, I have an x plus 3 minus 1, which is an x plus 2. Sure enough, there go your x plus 2s, and now when you plug in, you're going to get a 5 times a root 1 plus a 1, which is going to be a 10. All right, let's go ahead and try B, and then we'll call it a day for this video. All right, so Same thing, I plug in, I get 2 times 2 minus 4, which is totally a 0, on top of a 4 minus 4, which is totally a 0. So I know that I'm going to have to simplify, and I do that by creating a difference of squares. So I'm going to times the top by 2 root x plus a 4, right, because this is my a minus b, and I want to multiply by a plus b. And I'm going to do the same thing on the bottom, 2 root x plus 4, right? I'm going to FOIL the root floor, which in this case is the one on the top, right? So when I FOIL them, I'm going to get 2 root x times 2 root x, which is a 4x. Outer and inner will cancel. They'll both be an 8 root x, but one is positive and one is negative. And then I'm going to get a minus 16. On the bottom, I get an x minus 4 times this ugly 2 root x plus 4. Now, the top has a GCF of 4, and if I factor that out, it's going to cancel this factor. So I get limit as x approaches 4 of a 4, because that's the GCF, times this x minus 4 over this x minus 4, which is totally going to cancel, times this 2 root x plus 4. So when I plug in, I'm left with a 4 on the top, and on the bottom, I get 2 root 4 plus a 4, which is 4 over 4 plus 4, or 4/8, which you can leave it as 4/8, or you can make it a half. Okay? So that's simplifying algebraically so that you can evaluate limits.